In 1812, something remarkable happened. The British government began dumping stone into the sea at Plymouth Sound, all sparked by a small idea, and without building anything on top, without bridging it, simply lowering millions of tons of quarried limestone directly onto the seabed, one barge load at a time, relying solely on the mass to withstand the Atlantic. No mortar, no cement, no mechanical fastening of any kind. The project would last 29 years, consume approximately 4 million tons of Devon limestone, and cost £1.5 million, a sum that at the time did not account for the fact that it would be worth over £150 million today. When completed, it sat in the open sea like a reef, silent, almost invisible at high tide, and entirely immovable. And it still stands there, 212 years later. By making a small gesture and clicking the subscribe button beneath this video, you perform a small action with great significance to us. By pressing it, you understand that the matter is not about the magnitude of the act, but its meaning. It shows that the effort, the late nights, and the discipline required to bring this forward mattered to someone on the other side of the screen. Like the video, subscribe to the channel, even leave a comment below suggesting which structure you would like us to cover next. The Plymouth Breakwater stretches 1,524 meters across the open waters of Plymouth Sound, a natural harbor on the South Devon coast. At its widest, the base measures 300 feet. At its highest, the crest rises 20 feet above the low water mark. Beneath the surface, the stone descends far deeper, a broad, compressed wedge of rubble resting directly on the seabed, constructed not with precise jointing or engineered connections, but by sheer accumulated weight. The structure shelters approximately 4 square miles of anchorage. In a direct Atlantic gale, the water within it barely moves. The problem it solved had existed for as long as Plymouth had been a naval port. The Sound is one of Britain's finest natural anchorages, wide, deep, and enclosed on 3 sides by land. The 4th side opens directly southwest into the English Channel. The southwest is where Atlantic weather comes from. For the Royal Navy, which had operated continuously from Plymouth through the 7 Years' War, the American Revolutionary War, and the Napoleonic Wars, this exposure was far from a minor inconvenience. In the great storms of January 1807, more than 300 vessels sheltering in the Sound were driven ashore or damaged beyond repair. The losses of ships, guns, cargo, and men forced a decision that successive administrations had deferred for generations. Plymouth Sound required a permanent breakwater. John Rennie the Elder was commissioned to design it in 1806. Rennie was among the most capable civil engineers working in Britain at the time. He had designed Waterloo Bridge, redesigned London Bridge, and carried out drainage works across the English Fens. His solution for Plymouth was not architecturally ambitious. It was structurally absolute, a continuous rubble mound of loose limestone blocks stretching from Shovel Rock on the eastern side of the Sound westwards to St. Carlo's Shoal, spanning just under a mile across the harbour mouth. No excavated foundation, no binding material. The stone would be quarried at Orriston, on the eastern bank of the River Tamar, loaded into flat-bottomed hopper barges fitted with hinged hull doors, sailed 2 miles out into the Sound, and released onto the seabed. Continuously, for however long it took, work began in August 1812, with a workforce that would eventually number several hundred men across the quarry site, the barge fleet, and the construction supervisors on the water. In the early months, the operation placed approximately 100 tons of stone per working day. As the organization expanded and quarry output increased, peak daily placements exceeded 1,000 tons. The blocks varied in size from half a ton to 5 tons each, large enough to resist displacement by wave action once settled, yet small enough to handle without crane equipment, which did not yet exist at the required scale. What the surface operation could not reveal was the behavior of the stone once it entered the water. The seabed in Plymouth Sound is soft, a layer of accumulated sediment over bedrock, offering no rigid base. Stone dropped onto this surface did not remain where it landed. It sank into the sediment, spread laterally, and compressed the substrate beneath it. In the early years of construction, vast quantities of stone appeared to vanish entirely. The mound grew far more slowly than the tonnage figures suggested it should. Rennie had anticipated this, at least in part. His specification called for the base of the breakwater to be laid far wider than the finished crest would require, a broad, flat spread of compressed rubble that would consolidate under its own weight over time and provide a stable foundation for the upper structure. What he had not fully anticipated was how effective this process would become. As the base consolidated and the mound rose towards the waterline, the entire structure began to behave in a manner never before observed at this scale. Wave action that displaced blocks from the upper crest and exposed seaward faces did not damage the structure in any permanent sense. The displaced material rolled down the seaward slope and came to rest lower on the face, where it added to the base mass and increased resistance at the point of maximum wave impact. The breakwater was, in effect, repairing itself under storm attack. This self-stabilizing behavior of rubble mound structures would later become a founding principle of coastal engineering as a discipline. Plymouth was the structure that proved it. John Rennie the Elder died in October 1821, 9 years into the project and before the mound had reached the waterline. He left detailed drawings and specifications. His son, John Rennie the Younger, who had trained under his father and would go on to complete the rebuilding of London Bridge, took over the Plymouth Commission. The younger Rennie designed the finished upper structure, dressed limestone blocks on the seaward face, angled to deflect wave energy upwards rather than absorb it directly, a flat walkway along the crest, and a lighthouse tower at the western end. The lighthouse, a plain cylindrical granite structure, was completed in 1844, 3 years after the main breakwater was officially declared finished in 1841. Storms in 1817, 1824, and 1852 caused significant displacement of upper course material on the seaward face. After the 1817 storm, which struck before the breakwater had even reached its designed crest height, emergency repairs required the placement of an additional 50,000 tons of stone to restore the profile. Each storm confirmed the same pattern. The base mass remained undisturbed. The core rubble, compressed by its own weight into a formation denser than the seabed it rested upon, had not moved. Damage was always to the upper exposed sections, the dressed facing, the crest walkway, not to the consolidated foundation beneath. Criticisms of Rennie's design during construction, that the stone placed in the lower sections was excessive, that a narrower base would have sufficed, were answered by each storm that left the base intact. Cost arguments never entirely disappeared. 1.5 million over 32 years for a structure that is barely visible from the shore at high tide was a difficult figure to justify to a treasury simultaneously funding a European war. Alternative proposals circulated during construction: inner harbour walls, floating boom defences, a shorter breakwater of reduced specification. Each alternative offered lower initial costs. None provided the same level of protection for the entire anchorage, for vessels of every draught in the worst conditions the Atlantic could produce. Rennie's position, held by the elder and maintained by the younger, was that in open water against uncalculable Atlantic storm forces, mass was the only margin that could not be eroded by subsequent calculation. He was correct, as later calculations confirmed. Today, the Plymouth breakwater looks much as it did in 1844. Walk to the western end of Plymouth Hoe on a calm day, and you can see it on the horizon. A low grey line across the water, easy to miss, easy to mistake for a natural feature of the coast. It does not announce itself. There is no architectural ornamentation or commemorative inscription visible to a passing vessel. It is simply stone in the sea, placed there by men using hand tools and flat-bottomed barges over 29 years. The Royal Navy still operates from Plymouth. The Sound is still sheltered. The lighthouse at the western end still flashes its white and red sectors across the approaches to the harbour. The divers who worked on the lower sections of the breakwater during construction left almost no documentary record. The Admiralty tracked tonnage placed and weather days lost. It did not record names. Men in copper-helmeted diving suits, supplied with compressed air by hand pumps, from the surface descended into Plymouth Sound, in waters rarely exceeding 12 degrees Celsius, to inspect the mound's profile, reposition displaced blocks, and confirm that the upper courses were forming as Rennie's drawings required. The equipment offered minimal protection and no redundancy. A failure in the airline at 30 feet depth was a situation from which no one could recover. The breakwater records the labor of these men only as accumulated tonnage. The stone they handled is still exactly where they placed it. 212 years of Atlantic weather have not moved the core of the Plymouth breakwater. It has outlasted the navy that required it, the wars that justified it, the government that funded it, and the engineers who designed it. The Royal Navy still operates from Devonport. The Sound is still sheltered. The lighthouse is still active. A project of this scale initiated today would face environmental impact, assessments running to thousands of pages before a single stone entered the water. The procurement process, safety reviews, consultation requirements, contractor oversight, the cost, adjusted for modern construction economics, would likely exceed £2 billion. Throughout, there would be pressure to find a cheaper solution, a shorter structure, a lighter specification, something optimized for minimum acceptable performance rather than maximum proven durability, something built to last 50 years and then reviewed. Rennie, however, built to last with no review date in mind. The 4 million tons of limestone he dropped into Plymouth Sound are still there, still settling, still adjusting under Atlantic wave action, exactly as rubble mound mechanics demand. Here again, you see a megastructure born from the intelligence of a talented engineer. If you would like more videos like this, please like the video and subscribe to the channel.